Welcome you all. In this session, we are going to see the problems related to designing of stator main dimension. So the problem goes like this: calculate the diameter of core, length, size, and number of conductors for a 15,000 kVA, 50 Hz, 11 kilovolt, 2-pole, star-connected silent pole, cylindrical rotor alternator with an armature winding having 600 phase spread. Assume average magnetic flux density B average is equal to 0.55 Weber per meter square. Electrical loading AC is equal to 36,000 ampere conductance per meter, and current density is equal to 5 amps per millimeter square. Peripheral speed VA is equal to 150 meter per second. A winding should be arranged to eliminate fifth order harmonics, and synchronous speed ns is equal to 50 rps, that is in terms of rotations per second. Okay, so now you are supposed to calculate the D and L, that's the main dimension of machine, the diameter of core and length, size and number of conductors. These are the things you are supposed to calculate. So let us see one by one. So the given data ns is equal to 50 rps and number of poles is 2, peripheral speed is 160. So peripheral speed is given as 160. The formula to calculate peripheral speed is VA is equal to 5D-NS. Here NS value is known and VA value is known. So from this expression, it is easy for me, or it is directly calculate the value of capital D, diameter, which is equal to VA by pi into NS. So on substituting the values for VA and NS, you'll be getting the value of D. So the diameter of core D is equal to 1 meter. Now distribution factor of 60-degree phase spread is in order to eliminate the fifth order harmonics, and KD is equal to 0.955. So cos phi alpha by 2 is equal to 0. So from this alpha is equal to 36 degree. So the pitch factor is cos alpha by 2 0.951. So kW value is kp into kd. So we know the value of kp and kd. On substituting the values, you are getting as kW is equal to 0.855. So kW is equal to 0.855 in order to eliminate the fifth order harmonics. So now let us calculate the L value with the help of output equation. We know that the output equation d square L is equal to P by C naught NS. So we know we need the value of C naught, output coefficient. So let us calculate the output coefficient first. So the formula to calculate output coefficient C naught is equal to 1.11 pi square F P average AC KW. So KW value we have already attained the value of KW. B average value is directly given in the question. Frequency is also given. So on substituting the values, I am getting C naught is equal to 186.248. So this is the value I am getting for C naught. On substituting the value of C naught, NS and P in the output equation, I will be getting the value of L, that is the length of core. Length of core L is equal to 1.6 meters. Already we have found the value of diameter D. Now L value is known. Now the only parameter which we need to find is the number of conductors. So in order to find the number of conductors, you are going to use the T phase formula. So the formula is T phase is equal to E phase divided by 4.44 F kW 5 into poles. So here you need the value of 5. So phi is equal to 5D average. So from the specific magnetic loading formula, I am going to calculate the value of phi. The phi I am getting is around 2.7 Webers. So on substitute, this is phi. Phi per pole is 5 divided by number of poles. So dividing by number of poles. Here the number of poles is 2. On dividing, I am getting a value of 1.38 Weber per poles. So now substitute the value in the T phase equation, so that I'll be getting the number of turns per phase. So the total conductors Z is equal to 6 turns per phase. Conductors per slot is equal to Z by 2 into poles. Before that, total conductors I am getting is 144, and conductors per slot is 144 divided by 4, that is 36 conductors. So the total number of conductors is 144 conductors are recorded in stator, and the slots is conductors per slot. In one slot we go for 36 conductors. So these are the parameters, and this is how you need to calculate the main dimension problem with respect to stator for synchronous machine. Thank you.